Got questions about the Brazos, no more unknowns. Ever wonder where that water comes from or where it goes? We're unpacking the Brazos River.
We usually think of data collection as this sterile, infinite desert of Excel sheets and blinking cursors. But for the aquatic scientist of the Brazos River Authority, data entry often involves a vase full of water, wild Texas weather, bug hunting, and unexpected finds. And let's be real, this job is not for the weak. You gotta be a specific flavor of built different to spend your Tuesday chest deep in a stream bed, vibing with the murky depths, identifying a whole world of species. We are talking triple-digit Texas heat endless road trips and the kind of brain power needed to maintain the rigorous standards and repetitive work of testing water quality across the Brazos River Basin. The BRA's highly specialized field operations team are the ones doing the gritty and essential data gathering, from finding bugs to mapping out the physical soul of the basin. Lucky for us, we've managed to lure in a few of these legends back to the office to explain why they do what they do. If you think your Monday morning was rough, wait until you hear about what these guys do before 9 a.m. I'm Charlotte Shugart, and this is Unpacking the Brazos River. Joining us again is Field Operations Manager Jeremy Nickolai. Thanks for coming back.
Man, happy to be here.
I'm so glad you were willing to do this again. Yeah. Didn't scare you away the first time.
Not even a little bit.
So I hear that this is probably your last time.
Yeah, I am retiring, semi-retiring.
Congrats.
Thank you. Thank you very much. So yeah, April 30th is my last day, and we'll see where life takes me after that.
Yeah. Well, on that note, Cory Scanes has been promoted to Aquatic Sciences Manager, succeeding you. Congratulations.
Thank you.
Since this is your first time on the podcast, tell everybody a little bit about your history with the organization.
So I've been with the Brazos River Authority for about 7 years now. Was hired in as an aquatic scientist 1 and worked my way up to eventually taking over Jeremy's position. I've been interested in water quality since I was a kid, so I pursued a career in that.
Yeah. Okay, great.
Yeah.
Well, we are also lucky to have aquatic scientist Ryan Byrge joining us. Thanks for being here.
No worries. Yeah, it's great and it's a pleasure.
Tell us a little bit about your history with the organization.
Well, I've been with the organization now for 9 years. One of the main roles that we have as aquatic scientists is to collect water quality for the Clean Rivers program and the in-stream flow program. So I've been doing that for 9 years, and as of recently, I've been doing a lot of the bug identification, so that's been very exciting. So just continuing on that, moving forward.
Great. Okay. Well, Cory, you touched on this a little bit, but for you guys, how did you end up in this field? Was it something from your childhood? You were like, I have to play in the water when I'm older, or did you kind of fall into it once you got to college?
In college, I really didn't know what I wanted to do. So one summer, one of my professors was like, hey, Utah Division of Wildlife Resources, this guy I know, he has some summer work if you want to do that. And I was like, yeah, sure. So, it was mostly office stuff. And then I guess, once he decided that I was capable of doing other things, we went out, and this is in southern Utah. So we went out to the Virgin River down there, started pulling seines, looking for fish and stuff like that. And I'm like, wait, I can get paid to do this? And I just kind of fell in love with it after that.
Not for you?
Well, growing up, I was always outside and fishing my whole life. And I got my associate's degree at Hocking College in Ohio. And that's where I first took my first ichthyology class and ornithology. And, I was always interested in that. I had multiple different careers after that. But going back to college, I really started working. I worked for the Nevada Department of Wildlife in the summer, and that's kind of the direction I knew I wanted to be, an aquatic scientist, a biologist, looking at fish, bugs, looking at the water quality, because it's important to me, so.
Yeah. So how do you explain to people what it is you do, what you do?
I always start with, we're biologists. That's what we studied. That's why we're here. Most of us are here for the fish, the bugs, the critters, that kind of stuff. We get to do some of that, but largely our bread and butter is water quality. If we get questions about what do you do, some of that is boat, some of that is hiking down and pulling water quality from a creek. It could be a pretty creek, it could be a nasty creek. By and large, what we do is to ensure the quality of the water is safe, for recreation, for drinking, for all of that, and that it's sustainable for future generations.
Doing this for 18 years, you know, with the BRA, you kind of get like a rote answer.
Right, yeah.
It's like, well, we do routine water quality monitoring and biological assessments in the Brazos Basin. Usually the next question is, well, how's the water? The water's fine.
Depends on where you're at.
Yeah. Depends on where you're at. And then it
that's what I
goes to
always
like,
say.
what kind of fish do you catch? You know, and nobody's really like interested in like and which was mostly what we catch are like the smaller species of fish and stuff like that.
They want to know what the biggest thing is, the weirdest thing.
Yes. So that's kind of how that always ends up going down.
I mean, for me, you know, I always tell, like, even just going back home or whatever, I'm an aquatic scientist. So, you know, my job is to monitor the water quality throughout the state of Texas. And I always go, well, I mean, have you ever heard of the Clean Water Act? So that's like, it can relate to a lot of people because since that's happened, you know, I mean, it's been a significant piece of legislation that's cleaned up riverways throughout. I'm testing the water, you know, and I'm also looking at the fish species and bug species in there and just looking at the overall health and over the years and monitoring sites. So that's exactly what I try to relay to them. You know, like our job consists of collecting biological data, but a lot of times there's a lot of other skills that you have to do. You know, you have to be able to fix things and be out there and then adapt to things going wrong all the time. I mean, if it can happen, it will happen. So the one time with the throttle being broke 3 miles upstream, we weren't going to get back unless we fixed it, you know? So a lot of the things about being an aquatic scientist aren't necessarily, oh, I'm looking at bugs and doing all the cool stuff. It's being able to adapt to the situation.
If you get stranded on the water.
Yeah,
Oh,
like be able
man.
to, like, you're not going to be collecting anything anymore if you can't have some of the ability to think outside the box.
You know, and I think this goes for like any job across that anybody does. There is like the romantic vision of what a biologist is.
Absolutely, yeah.
You're out there and it's 73 degrees and the wind's blowing through your hair and you're scooping up all these fish and boats magically appear in the water and magically appear back up on the trail. It's not like that. It's rigorous out there and physically, sometimes emotionally.
Yeah, long hours. Yeah. I mean, we all know about that, being from sun up till being out there until it's dark.
Sun up
you know
to
what I'm saying?
sundown,
It's
yeah.
not
As hard as it is, you know, one of the best parts about working in the field and working hard is like that shower after a long day, you know.
Hands down. Every time it'll be the best shower you've ever had.
You've been tromping around in Finkel meringue for 8 hours and you're just like,
yeah,
That's a mental image for you.
and you smell like carp because you've been counting carp and you got like
poison
scales
ivy
on you.
everywhere.
Oh my gosh.
Yeah.
Bug bites.
To do what we do, you have to be adaptable and durable.
Yeah.
If you can do that with a positive attitude, it makes the day go by so much better. And like, we're all cut from the same cloth. And so when we're out there and it's miserable and you just start laughing,
Yeah.
you're like,
Yeah.
your waders are full of sweat, not water from the creek. Your waders are full of sweat. You can feel it down in your
Socks.
feet. You can't help but laugh. And when you winch that boat back up the steep riverbank,
Yeah.
and you take a swig of water or whatever it is, eat a piece of beef jerky, you're like, we made it through that together.
Yep. We did a thing. We just did a thing.
And that is rewarding.
Absolutely. Those times when you do have to launch boats off cliffs or wherever else that you're doing it, I mean, it's massively rewarding. Yeah, just being able to be durable and having an award-winning attitude out there, right?
Yeah.
That's right.
The award-winning attitude.
AWA.
That's a Ryanism right
Yeah.
there.
AWA.
Well, we stand our resilient aquatic scientist. Yeah, there's a lot of different aspects, and we're going to kind of delve into a lot of that. But what would you say is really the primary mission, the primary goal, the objective of the field operations team?
For us and for me and is the Clean Rivers program, and it's there to assess, monitor, and improve the water quality in the state of Texas. So that's, you know, implemented by the Clean Water Act. That's our main goal. That's our bread and butter. That's what we do, you know, monitor over 100 sites. So
Yeah, and so just to expand on that a little bit, the Texas Clean Rivers program is run by the TCEQ, which is the Texas Commission on Environmental Quality. The Clean Rivers Act requires an ongoing assessment of water quality issues and management strategies statewide to guide Texas water resources policy and decision making. The Texas Clean Rivers Act came online in 1991, forging partnerships between the TCEQ and river authorities to monitor and manage water quality issues.
So that data that we collect gets submitted to TCEQ, and TCEQ uses that data to assess all the different water bodies in our basin. And so if there's an impairment, and I think probably everybody knows that like bacteria can be a big impairment, and that's usually what people think about. That impairment will go on the 303D list. And
Nobody at home knows what that means.
okay, so the
303D list is the impaired
It's a list of
for-
it's a
impairments.
list of impaired water bodies.
Those impaired water bodies have exceeded the limit of either nutrients, bacteria, low dissolved oxygen, and that's over time.
Yeah, TCEQ has set standards for like dissolved oxygen, bacteria, nutrients like nitrogen and phosphorus, which are detectable through the tests that we run on the water that we collect.
Once a water body goes on the 303D list, the list of impaired water bodies, that prompts some action. Like, okay, we need to do something about this. And you could do a whole nother podcast on the two different ways that that's taken care of. That's what happens with our data is
Those impaired segments, well, they have to be addressed, like improved eventually. Those could be like different programs with like a watershed protection plan that helps improve it, or they call it a total maximum daily load. And that's like a program that'll go in to improve those waters over time.
And things like that are usually implemented by stakeholders in the area. Like right now in our basin, there are several watershed protection plans that are either active or have been wrapped up or are about to start. Places out near Stephenville, we have some issues with pollutants that are in some of those smaller creeks and water bodies. And so they're impaired for maybe dissolved oxygen and chlorophyll, which when you have a lot of nitrogen and phosphorus, algae wants to grow and it'll choke out other organisms that live in that water body if there's not enough flow to wash it out.
and cause big swings in dissolved oxygen because, algae during the light, it makes oxygen. And then when it gets dark, it pulls the oxygen out of the water. So during the daylight hours, the algae will make oxygen. So those DO limits will go way high. And then during the dark period, the DO will drop way down.
Interesting.
Yeah.
Yeah.
So the basin is very big. Do you guys travel the full length of it? How many spots do y'all go to? What's that look like?
Yeah, I've traveled over 600 miles this week. So I went all the way from
So a little bit is what you're telling me.
PK on a boat, sampling Possum Kingdom, all the way to, Sugarland in Houston, doing Allen's Creek sampling. So yeah, it encompasses the whole basin. I mean, we sample over 100 sites, that's including 8 lakes. So we're all over the place in the basin.
We have a little over 110 Clean Rivers program sites that we sample. And then on BRA's reservoirs, we have additional sampling.
Yeah.
I think like 10, 12, 15, 37 additional sites that we sample water quality. And not all of our Clean Rivers program sites are sampled monthly.
Okay.
Some of them are sampled quarterly. And we actually have 2 sites that are sampled twice a year.
Biannually, yeah.
Yeah.
Well, why?
Yeah.
What's the rhyme and reason between how often you sample at locations?
We have a meeting every year. It's our coordinated monitoring meeting that we hold with TCEQ and other stakeholders and partners in the Clean Rivers program, where we determine our sampling schedule.
Yeah, it's a collaborative effort between multiple different agencies to sample a very large basin.
So kind of all the data that we collect plays into other parts of the BRA too, like our in-stream flow stuff and part of the water management plan. So, I mean, it's not as willy-nilly as it sounds. The one that we do biannually is
John Graves, and that's part of
compliance.
legislation.
Yeah, so we're legislatively
has to be monitored.
mandated for that one.
Yeah.
And that's kind of a cool program too, because you have to do visual surveys over. So you have to we work with Texas Parks and Wildlife, and they get their helicopter out, and we fly like the John Graves waterway there.
That's cool.
And I got to do that last year.
Nice.
And they have the helicopter ride, and then they have a airboat that
yeah.
goes up and down, and that's basically from Granbury up to PK. But part of that legislation that went through was because of like illegal mining operations. So that's what we were looking at, like from the helicopter. So
I need to know how I can get in on that.
Jeremy volunteered for, he's like, hey, do you want to go? And I was like, absolutely. And it really is an experience.
I bet.
I've never been in a helicopter, but to see how beautiful it is from Granbury up to PK is like a stretch of the Brazos that a lot of people don't get to see. And I got to see it from a helicopter. I mean, you can canoe it, which is absolutely something I want to do someday with one of these guys here, maybe. But
At least one of these guys.
it's a pristine part of the river. And
So when you say you guys go out and take water quality samples, what does that mean? What does it look like when you are doing that?
basically, we're taking like physical and chemical measurements of the water quality, the temperature, the conductivity. And what we use is it's a sonde, a water quality sonde.
I don't know what that is.
Yeah, it's called, we have a specialized instrument or a piece of equipment. It's like a tube with attached to a line, and then it goes into the water and you pull it, and it basically retrieves 2 liter, 3 liter, 4 liter sample, pull it up off the bridge, because a lot of the sites that we have are off of bridges.
Okay, why?
Just public access. That's basically, I mean, a lot of these sites that we have, the only way we can get to them is from a bridge or public access, you know. Anyway, that piece of equipment comes to the top, and it's got like a tube attached to it, and that's where we fill our water bottles up, put them on a cooler, and then they go back to the lab for them to analyze and, you know, determine those measurements, and all that data goes back to TCQ eventually. So we're testing for temperature, dissolved oxygen, conductivity. We'll test for pH, and those are just like instantaneous measurements of the river at that time that we're sampling. We have certain water quality bottles samples that we'll retrieve from the river, and those go back to the lab where they'll test for nitrates, nitrite, total phosphorus, ammonia, chlorophyll, and all. So that's like kind of a typical day when we're out at a particular site sampling that.
In some of our sites, you know, we can actually get into the water, and then we'll just physically dip the bottle into the water and then put the lid, you know, and do all the things. And on the boats, it's the same thing, you know.
Sometimes we have like a cup on a really long hand, and you want to reach out pretty far. You can get a sample pretty far out into the water body on some of these with that.
It's handy when it's cold, when the lakes are cold too, you know.
Yes, your hands aren't freezing and wet in the summer months. When it's hot, you kind of want to get your ankles wet, and so we'll just wait out and sandals or wading shoes, that kind of thing.
However you can get it.
Yeah, however.
And that could be
whatever kind of comfort you can get.
Yeah, never give up. Yeah.
So y'all can access either on the lake through the boat. Some places you can actually walk into the water body, but other places you gotta dangle off
The bridge.
equipment off the bridge.
Equipment off the bridge.
Yeah.
Truck parked on the bridge, flashers on, and that's a lot of our sites. There's only a few sites that maybe we access on private property, like the North Bosque. Have to get landowner permission, and generally people are wonderful about it. So
Yeah.
The variability of these sites is pretty remarkable. When we're up in the upper basin, our furthest site up the basin is our Seymour site. Seymour, Texas is probably a population of what, 50 people? I mean, it's probably.
yeah, it's
nobody
very
from
small.
Seymour hears
It's
this.
not a large town.
I don't know why 800 sticks in my mind, but
You're kind of in the middle of nowhere up there.
mhm.
You know, we've got stations down south that are in the middle of Sugarland. They're basically in the canal system, and we can see people's houses or a golf course, you know, and stuff like that. You know, our furthest south site, Rocheron, it's again like you're out in the middle of nowhere.
But yeah, it really is amazing from Seymour to Rocheron, the difference in the river. And I mean, you would expect that because that's how drainage and in a watershed works. But at Seymour, it's red dirt, it's shallow, it's saline. It's so very different than the big, mighty river that you experience at Rocheron, where it's rushing, it's brown, it's
a lot, and
the
a lot of
It's a large river down
there.
there.
Yeah.
the banks are really incised, and like you can see where the river has cut the land.
So our upper site, we'll go there, and it might be running like, and this is main stem, like, I don't know, 5, 10, 15 cubic feet per second. Whereas when we get down in the lower basin, it's running
6,000.
10, 15,000 CFS, and then sometimes even more than that when we've had big rain events and stuff like that. And that river gets big, 60, 70,
60,000, yeah.
CFS down there. And
Yeah,
that's-
we've seen
that's a
some large
big,
flows
big
over the
river.
years. Over
Yeah.
past 5 years there's been a lot of big, large releases out of Granbury. I mean, which is typically not how it goes, but that's
So when you guys go out and you use your equipment and you pull the water samples and you document what's there, then do you turn around and that's what you submit over to TCEQ, or?
Like us going out and collecting the data is just like kind of this first step, and I'm going to get a little into the weeds here. So we go out, collect the data, and collect our water samples. We enter the data, and then we QC the data, make sure everything is correct and all that stuff. Those samples go to the lab does their thing, and there's a whole analysis process, then a QA/QC process, and then our QA/QC staff looks at that data and makes sure everything's good to go. If everything is good, every quarter we do a data transfer where all that data that we're contracted to send to TCEQ gets packaged up, and then it gets sent to TCEQ. And how often do they do the assessment? Is it every
the integrated report is every 2 years.
2 years?
Yeah.
That's when they do that assessment to see how those water bodies are doing.
I just want to clarify that when these guys are bringing samples back to the office, they are talking about the BRA's central office located in Waco. We have a lab here that is accredited under TCEQ, under the National Environmental Laboratory Accreditation Program, or referred to as NELAP. They're a big deal over there. So what happens once the samples are in the truck? Are you driving around in a mobile science lab for a week?
It's
or
called-
is it a race to get back, or what's
No,
that look
so
like?
our samples have varying hold times. So we collect one sample that needs to be processed within 8 hours, and that's bacteria. We have this fancy new extended hold time, which is 30 hours, which we're really excited about because that allows us to kind of expand some of our work. But generally, we go out, we collect, and we come back day of because we have to get E. coli or Enterococcus processed essentially within 8 hours. We have other samples, maybe that hold time is 72 hours, so 3 days. Some of our samples can be held for 20 plus days. We put our samples in the cooler. When we come back, we immediately process E. coli, and then the lab takes in those other samples, and they'll hold them for however long it takes them to run their various tests on those samples.
Do the priority ones first, the shortest shelf life.
The hold times and their scheduling and everything like that in order to get all the samples processed within those holding times.
It's a little bit of a race.
Yeah, and our scheduling too during the week. How many runs that we do during the week determines like how many samples they can process.
Yeah, trying to make the most efficient use
Yeah.
of time, and
Yeah.
it's a juggling act is what that sounds like.
Most definitely.
It all has
It
limits
definitely
and
is.
And then you throw weather into the mix,
Yeah,
and
and
that
That's a whole nother animal. With bacteria, because it's a living organism, unlike nitrate or orthophosphate, something like that, it's just, chemicals. Because it's a living organism, we can't keep it in a bottle for too long before the cells start to die, and we will no longer be able to detect them with the tests that we.
And it won't be representative of when we collected that. If we let an E. coli sample sit for 2 days, they're going to,
maybe half the colony is dead.
So then that's all about the data integrity. So they put limits on it. This is like the time period of when you're going to get the most representative amount of E. coli in that particular sample.
So we test all our sites for E. coli. So, it's not whether if we know it's there or not. More than likely, it's going to be there unless, the lakes a lot of the times.
Bacteria is always everywhere.
Yeah. it's
So I know you guys just said bacteria is everywhere, but for most people listening, what they're hearing you say is there's E. coli everywhere. Why is that not a panicky thing that I feel like some people are going to hear and be like, that's not good. I don't want to be in any water with E. coli.
When TCEQ sets their standards for bacteria, for E. coli or Enterococcus, so to differentiate first between Enterococcus and E. coli, we test for Enterococcus only at our 2 uppermost sites where there's a higher salinity. The testing limits within those kind of denote what we're testing for there. When TCEQ sets their standards for bacteria, they base it off of what kind of recreation is at each of these sites within these stream segments. segments. And if there's primary contact recreation, so people swimming, tubing, all of that kind of thing. So I'm thinking upper Brazos, below PK, there's a big canoe and kayak rental there, and they'll shuttle you. For stream segments like that, the total number or the actionable number for E. coli, I think, is 120 or 125,
yeah.
something like that, MPN, which is a measure of how much E. coli is in that. That's really a pretty low number. And usually in those areas, what we find is 20, 30
Well below
MPN.
that.
So very little E. coli. E. coli may be there, but it may not be at a level that's going to impact that recreation. So for sites with essentially secondary recreation, that MPN number is around 600. So these are sites where maybe you're wade fishing or you're fishing from the bank, or you'll see boating or something like that, but no swimming. Swimming is considered primary contact recreation. And so in the secondary contact recreation areas, that number is much, much higher than it is for primary contact. Through our tests, if we detect something that is over one of those limits based on that recreation, that throws up a red flag, and that becomes an impairment. And if it makes anyone feel any better, like when we're out doing biological sampling or water quality sampling, anything like that, we're not really washing our hands, and we're eating our sandwiches and, and I mean, maybe our gut bacteria is a little stronger than everybody else's, but I mean, I've eaten sandwiches in some nasty rivers without hand sanitizer or washing my hands.
Yeah. I mean, there's always going to be some risk. No water is ever completely safe.
Yeah, I've never intentionally gulped the river and taken a big drink, but
it's not recommended.
Even in most pristine streams I've surveyed, but I usually use my water bottle that's come out of a faucet, but I wouldn't recommend that anywhere.
You mentioned the weather earlier. Texas weather is crazy. It's all over the place. Do y'all measure throughout the year or all weather conditions? What's that look like?
We go all the time. I'd say maybe we're like the postman. We've been on the lake in sub-freezing temperatures, going 45 miles an hour on the boat.
I would have called it a day right then and there. Respect.
We've electrofished in the rain, hot temperatures where you're sweating. We have a pretty good crew who is very aware of like safety hazards in inclement weather. We can recognize heat exhaustion in each other and in ourselves. And so we've had some times.
Yeah, but for the most part, I mean, we're sampling it regardless, unless it's unsafe, which we've all had plenty of experiences on boats with, high winds or thunderstorms, and we're all amateur weathermen.
Yeah.
Constantly looking at the weather and, seeing what the systems are moving through.
Mm-hmm.
When I first started here, I mean, there's barely internet. I'm just joking, but we'd kind of get in and we're going to go up to PK and do some sampling and stuff like that. Looks like about a 30% chance of rain. Let's go. We're going to go do it. So we're on our way to PK, and we don't have any like cell phones like we do now. We have flip phones.
Yeah.
And so it's not like it's something you can continuously monitor. And so you get to the lake and it's raining cats and dogs and lightning everywhere. And you're just like, well, how long do we wait this out?
Yeah. How long is this going to last?
So there's nothing. I mean, we can't get on our phone and look at like the radar.
Yeah.
We're
Which
sitting
is
in the
huge
truck,
advantage these days.
watching, and that's where I was going. Is
Massive
like,
advantage.
We've come a long way, and with these forecasts now, I mean, you can like run a radar and it'll show you like what the storm's going to be doing 4 hours from now. So
Mm-hmm.
going off on a tangent here, but I think that's like made us better at what we're doing, because now we can manage the schedule a little better.
And that's the complicated part.
Yeah.
That's an old timer's perspective right there.
The weather's not going away. We just have to learn how to deal with it. The more experience you have out there, the more you become well versed in knowing, what it's going to be like.
Yeah. And when it comes to like wind and our lakes, these lakes are kind of our babies, and we kind of know what they're going to be like. They're temperamental, and we know what they're going to be like based on the forecast. We know that Possum Kingdom at 10 miles per hour winds, sustained winds, is going to be fine for us to sample on. But we know that 7 to 8 to 10 miles per hour on limestone is going to be a hard day.
Yeah.
So
Why is that?
The lake is positioned north to south too. I mean, so when you have a north wind on limestone, even if it's 5 to 10 miles an hour, it's got the whole fetch of the lake. So you could develop whitecaps, wind.
and limestone is just a big bowl.
Yeah. And then, you know, like PK and Granbury, they're like snake shaped. So there's a lot of wind breaks and stuff like that. So you can know, I mean, anything over 30 miles an hour, you wouldn't want to go out there, but you could. I think we could all safely navigate it, but I mean.
So taking water samples is just one part of it.
Yeah.
Tell us a little bit about the other side.
Like the biology part.
fun side.
That's the fun side. Yeah.
Well, that also goes into the Clean Rivers program because that's also a standard that they create for aquatic life use. So we're looking at the fish, the bugs, the habitat gets a score of some sort if it's limited or if it's high or exceptional and stuff like that. So, you know, we're looking at the fish species, how many fish species are there, different types of fish.
The diversity of this.
How many of them are there? That gives us an idea of how well the aquatic system is doing there. You know, looking at bugs, it's the same thing, but
Okay, so you arrive at a spot on a river, on a tributary. I mean, what does that look like? How are y'all going about doing all of that?
I'll do the bugs, but yeah, it's different than collecting the fish. I'm just looking for good habitat. I'm using a net. I'm basically kicking the substrate around. I'm collecting the bugs because they're really tiny, and then I'm putting them into a jar that goes back to the lab where we sit and pick them out and ID them under a microscope. A lot of like the mayflies and caddisflies and stoneflies are highly sensitive to like low oxygen or nutrients. So if they're not present, you can kind of get an idea of the diversity and the aquatic life use of that particular segment. So it gives us a snapshot of the water quality, the habitat. If there's no habitat there, then there's not going to be any bugs. So
more bugs, more species, the better the water condition, kind of? I mean, I've simplified it dramatically.
Yes, they would indicate that the water quality is there. Is higher there with, you know, dissolved oxygen, less nutrients coming in because a lot of those aquatic insects are sensitive to higher levels of that. So, and they would indicate that the habitat there throughout that segment is higher. There's a diversity of habitats, riffles, runs, pools, like the riparian zones intact.
So the bugs are the neighborhood gossips.
Yeah.
If they're stressed, we know the whole street.
Yeah, I mean, it's not only the bugs, it's also, you know.
It's fish and freshwater mussels.
So I think you bring up a good point. The bugs being the gossip. The bugs are near the bottom of the food pyramid there. They are kind of like the first indicator that there might be a problem, since the things that eat those need those to eat. That kind of moves up the food web a little bit. So yeah, bugs are a really good indicator of water quality, like an initial indicator. There's tolerant species, and what I mean by tolerant is they are more likely to survive in a disturbed stream. And then there's intolerant species where the more a stream is disturbed, the less likely they're going to be there. And like some of those species that he was talking about, the mayflies.
Mayflies, caddisflies. I mean, those are a good indicator of.
Yeah, they're intolerant species. So if you get some disturbance, they're going to be the first ones
to go. Yeah, they're sensitive too, and quick to be sensitive. So
yeah.
You know, some of the mayflies you can visibly see them, they're big, but there's no way, because the order of mayflies, and then you got families of mayflies that they're so small and you can't distinguish between them. You have to look at it. They look so similar if you're just looking at them visually.
Yeah.
So you have to take them back to the lab and look at them under the microscope.
Yeah, you're not talking about collecting like beetles and.
Well, we do aquatic beetles.
You do,
yeah.
okay.
Yeah, beetles, diptera flies, mayflies,
Dragonflies,
damselflies, all sorts of. It's a large discipline, and it's been an awesome challenge. But an area that's like we recently did, Brushy Creek and South Fork of the San Gabriel. We have over 25 different species of bugs that are in there. So they got higher scores on the index of biological integrity, so.
Okay, so now I am deeply invested in some bugs survival, but okay.
I mean, same way with fish though,
Yeah, so within each of these surveys, we have essentially two different projects that we're doing these biological assessments under, and one is the Clean Rivers program through the Surface Water Quality Monitoring program at TCEQ. The other is the Texas In-Stream Flow program, which was set up a long time ago. I won't go through the history of it all. I believe we have information on our website. We can direct people to that information on Texas Water Development Board's website and TCEQ's website. But it was a program that was established to assess freshwater inflow into the river system and into the bays and estuaries along the Texas coast. The BRA is tasked with performing biological assessments for that program as well. In our basin, I think we have 9 sites that we assess for that. And within each of those assessments for Clean Rivers program or for in-stream flow program, we do bugs, we have a habitat assessment, and we also do fish. The habitat assessment and the way that the protocols for each of those programs is a little bit different in the way that we conduct our field work, but the overall methods are the same. So for bugs, Ryan said he used, a kick net, and he's compositing them all into a jar. For fish, we use 2 different methods. We use electrofishing and we use seine net, which is a finer mesh net. We stretch it out and we drag it across the bottom and scoop it up and see what's in there. It's effective in some habitats and not effective in other habitats, but that's where that dual fishing methodology comes in handy, because where a seine net might not work, our electrofishing might work really well. So we'll pull that seine, we'll scoop it up, we'll work through the fish that are in there, identification of species. We take a total length measurements on a certain number of those species, and then we just tally the rest.
So you're pulling them out of the water, you're IDing them, you're measuring them, and then just putting them back in the water.
Putting them right back in the water. We are careful to not put them back where we may be going to sample next, so that we don't double sample them. Essentially with electrofishing, we do the same thing. We apply a current using a generator, or there's a backpack that's battery operated, but it creates a current. We apply that current to the water. It's a non-lethal method when used properly. The anode, which is essentially a metal ring that is attached, is applying the electricity to the water. The fish are attracted to that, and we net the fish as they come to the anode.
It stuns them too.
It can stun them,
Makes it
yeah.
a little easier to catch.
Yeah.
Yeah.
That's the
Yes.
point.
We used to do mussels for our in-stream flow program. We've backed off of that a little bit because we do have projects that are concurrent where mussel surveys are actually being conducted in a lot of these places already.
Oh, okay.
Um,
You're not duplicating efforts,
so
essentially.
we're not duplicating efforts, exactly. But we have a few people on the team who are fairly skilled at identifying mussels.
Because there's a lot of different types of...
There are, and their names keep changing, and so
Wait, really?
yes, it's hard to keep track of.
Yeah, they have over the years.
Yeah.
Science is ever evolving, and so we have this conversation like a lot. There's 2 different types of science. Well, there's lots of different, but as far as taxonomy goes, there's 2 different types of science people. Lumpers, people who like to keep things all together.
This fish looks like this fish, so they're essentially the same fish.
And then splitters. Oh, even though these fish look alike, genetically, they're separate, and
We monitor the literature and what's going on with mussels and fish and bugs to make sure that we have the right taxonomic name for each of the species that we collect.
Do you have to track or document any of the habitat surrounding the area that you're in?
We definitely do. So depending on which program or project that we're performing the biological assessment for dictates the methodology that we use for monitoring the habitat. But we are, with all of our projects, we're monitoring the stream bed, what substrate, so is it gravel, cobble, sand. We're monitoring the banks, what kind of growth, is it bare, incision, all of that kind of stuff. We are looking at the riparian area, so how intact is the vegetation up to the stream bank and going out. A good intact riparian is good for the stream and stream health because it's a better interface for drainage water coming into the water body. So it filters out some of that stuff, and it allows habitat and food and all of that for organisms that live in that area.
keeps sediment from, and the banks from washing away.
Definitely. We look at fish habitat. Is there large woody debris? So is there a big tree in there? Are there trees? Are there boulders? Stuff for fish to hide under, stuff for smaller fish to get away from predators and maybe get out of the heat, the sun. So bass like shade, are trees overhanging, stuff like that.
Yeah. So why does it matter? Why does it matter that you guys go out on a regular basis and track to that level of detail the bugs, the fish, the habitat in the area?
I mean, the Clean Rivers program is there to maintain and improve the water quality, and that's what it all comes down to. I mean, if you're thinking about the the Clean Water Act pre-70s, I mean, a lot of our rivers and streams were massively polluted and just in terrible shape. So, you know, that's why it's important, because we need to maintain and improve those water bodies over time, because ultimately that's all of our drinking water, and that's pretty much at its basic. If we weren't on the ground doing this, then who knows what the rivers and streams would look like. So
Just aside from like collecting those long-term data sets, just us being out there and being able to put eyes on the stream, we can identify problems and let people know if something needs to be taken care of.
Because is there anybody else doing this?
That's a really good question. And man, I've been like, I need to get this in there.
Okay. Now is your opportunity. Tell me.
So we are not the only ones
we are not the only ones.
that do sampling in our basin. The different regions that cover our basin in TCEQ do the same kind of CRP stuff that we do. Universities are doing all kinds of biological work. Water Development Board, you know, does some stuff.
Texas Water Resource Institute. they do
TWRI, yeah.
They do Clean Rivers
Yeah.
work.
EIH.
TIER at Tarleton.
EIH down
Yeah,
south.
Environmental Institute of Houston.
Yeah, so yeah, we're not the only ones out there collecting.
So, and like,
It's a coordinated effort.
yes, it is a very much a coordinated effort. We're not the only ones out here doing the CRP stuff. We're not the only ones out here doing like the biological work. You know, Parks and Wildlife does some stuff too. I mean, a lot of stuff. You know, there's a lot of eyes on the stream, and that makes me happy. Because I mean, shoot, dude, even if we had twice as many staff as we had, we still couldn't do all the work that everybody else is doing along with the work that we're doing.
Texas is a massive, massive state, and Clean Rivers program encompasses the whole state of Texas. So
Yeah.
I mean, there's a lot of monitoring that goes on.
Mm-hmm.
So did you guys already know all these different type of bug or fish species, or is it kind of a learn on the job? Or
For me, you know, I didn't grow up in Texas, and I didn't go to school in Texas, and all my fish experience had been in Utah. It was a pretty steep learning curve from, you know, these high desert streams and, you know, and stuff like that, where there's like 4 or 5 different species of fish, to some of our sites will have 15 or 20 different species of fish. And then you start moving across like the different physiogeographic regions of our basin, and the fish that we catch up in the upper basin are totally, more not totally, but they're going to be very different than the fish that we catch in the lower basin.
I studied this in college at Texas State University. There is a really good fish program for identification and taxonomy. So that is where I started learning. And then just through working here and my previous job, I think what's really interesting is those of us that have worked through a dichotomous key in order to ID species and key in on certain traits and characteristics, you can take that from fish to bugs to plants.
Absolutely.
Because you have that schema in your mind of how to differentiate these species. And so it's really a skill that you learn, but once you learn it, you can apply it in a lot of different places.
what's the fish on your hat right now?
This is a greenback cutthroat trout.
Okay.
It's found mostly in Colorado.
Not a Texas fish.
Not a Texas fish.
Nope.
When you guys are out there using the net and scooping a tributary bottom or the river bottom, I mean, do you ever pull up things that surprise you, or you're like, that shouldn't be here?
I mean, yeah.
Probably one of the most surprising fish that I've pulled out of a stream for work is grass carp. Grass carp aren't a native fish. They're used for vegetation management in ponds, and they get huge, like 2.5 feet, 3 feet. They're like water cows, man. They eat algae like crazy. I was like, what? Probably likely what happened was this fish was in like some stock pond somewhere, and it got flooded out and pushed into the river. But if you find one, you know, you kind of have to dispatch it so it's not doing harm to the environment, because it'll do a bunch of bad things.
I've shot a goldfish that was huge in Chicago. I've got a picture of it. It's pretty impressive. I mean, but like a lot of the armored catfish
Yeah.
that are aquarium fish, you could see those still surviving. But yeah, that goldfish was, I don't know, more than 12 inches. And it's just
And so this is a reminder for everyone listening.
Yeah,
do
do
not
not throw
dump your fish tank fish
Very adverse effects on river communities, fish species, anything else. But
Like in general, you're gonna find all sorts of stuff in these streams. I mean, from lawnmowers to bowling
yeah.
pins,
Dishwashers.
tires.
Washers and dryers?
Oh yeah. I mean, anything you could ever imagine, people will
people
throw
will
in the
dump in the
which
river.
is-
Yeah.
Yeah.
and it ends up in the
Dead
river.
hogs.
Yeah,
Oh my
I mean,
gosh.
At our site at Rocheron, all the way down. It was a year or two ago. I pulled up to the site, and there was a pallet of motor oil that I don't know if it fell off a truck or if someone had dumped it off the bridge, but it was just pouring motor oil into the river.
What did you do?
I let my supervisors know.
We'll let TCEQ know, and Texas Parks and Wildlife. Parks and Wildlife has a spills and kills team. You know, with things like that, our hope is that like there's some identifying something on those things that people can get held a little accountable for just
Sure.
dumping stuff
Yeah.
on there.
What's y'all's favorite story to tell people?
I mean, I really enjoyed the helicopter ride.
Yeah.
I mean, honestly, I'm going to say that because to see the Brazos up, above Granbury into PK, it's a beautiful place of the Brazos River.
Like a couple things come to mind, like Ryan and I were sampling our Upper Brazos run, and we drove from Graham to Seymour in like a snowstorm. And
Literally a snowstorm.
Literally a snowstorm,
Absolute legend.
which I trusted him because he's from Ohio. Like,
Well, we lived
I know
out,
he knows how to drive.
No, I mean, we both
and
have lived
he's
out
lived in
west.
Nevada.
And that was very typical of a, western mountain storm.
We left the hotel, drove in the snow, and got to Seymour and sampled our first site and worked our way back to Waco.
Yeah, one plow we saw. We saw one plow. I think we were behind it at one point, like, all right, let's you clearing the way for us.
It was the plow for the state of Texas.
Yes.
Yeah, in the northern state of Texas. I don't know. Because it was like, wow, it's like seeing an endangered species, But I mean,
So we were sampling the Leon River. We were doing a biological assessment, and this is just outside of Gatesville. And we're very close to the end of the day, and we're finishing up a little bit of our fishing that we had to do. And we look upstream, and there is some commotion happening on a small scale, but on the bank. And we're like, what on earth is that? And so Jeremy and I go up there and look at this, and it's a water snake wrestling with a catfish to get it down into its throat. It's trying so hard. I wish you could see what I'm doing with my body, but it's trying so hard to get this catfish up on the bank. And it's like the snake is throwing its body up onto the bank to try to get this fish up there. And I don't know how long we watched it, but Jeremy got video of it. And we were just like, that's incredible.
Yeah.
It's just something incredible to see.
Yeah, like watching nature do nature things, it's pretty neat. You just see odd stuff out there. We were out there, me and a former employee, Cal Corley, were sampling like the lower Brazos, and at one of the sites, our first site of the day of all things, we pull up under the bridge, and I can see this little flicker kind of out, and it's still like morning, so it's not like all the way bright yet. I'm like, what is going on there? And so the closer we get, I can see that like it's a candle, and then you get there and there is a dead chicken, a bunch of like chicken gizzard livers and hearts and stuff like that. And then this candle sitting there, and there's like pineapple slices and oranges and bananas and blood. It's like this whole little sacrifice thing. So here's the weird part. That candle hadn't been burning very long. So, and there's like, we didn't see anybody come in or go out, and I'm like, what the heck? So you're looking, and I don't see any footprints, and like there was like a sweet potato pie or something there, and like half of it was like, it looked like it had been like licked off, eaten, and the other half, I'm just like.
Is this the story where you came back and told people and they just thought you were lying?
no, I saw a picture of it.
No, we
and then-
totally,
yeah.
we see all kinds of crazy stuff.
Oh, yeah.
Like, we see the weirdest stuff. I was just down there, and there was a pile of probably 20 dead hogs.
Yep.
Right where we pull in to walk down
That's the
to go
most
take
I've
our
ever seen. You
samples.
showed me that picture.
Yeah, it's a lot. Because we go all over the place, one of my favorite things is the ever-evolving graffiti on bridges. Like,
It's just, yeah, it's wild. I've taken a lot of pictures of it. Maybe one day I'll make a calendar of it.
Oh,
We maybe should.
The Brazos
know,
River
like-
Authority graffiti. That's kind of my goal.
that is brilliant.
Pretty entertaining for sure. I always look for it because
It's pretty interesting out there. for
No doubt.
Sure.
You guys have any superstitions?
You never say the R word.
We're not in the field, you can say it.
So the R word is rain.
Mm-hmm.
If you say it, it's going to happen.
I think one superstition that I do have is that if it looks like it's going to rain and I take my rain jacket and I'm fully prepared for it, it won't. It's weird. There's a high percentage of times that I was like, I should bring my rain jacket. And if I don't, it'll rain. If I do, it won't. There's a superstition. It transcends like what we do, but you never bring a banana on the boat. And I'm not
I'm not
heard
that.
100% sure why.
you know, a boat carrying bananas, you know, transport. I'm talking a long time ago. I don't know, 1700s or something, like was out in the ocean. It sank. You see floating bananas. I've heard stories of like bananas.
Your boat's going to sink,
yeah,
you know,
and,
or you won't catch any fish.
Bananas carrying like insects that will bite you and stuff like that. But that's, yeah, that is a superstition for sure. I don't know if anyone's brought a banana electrofishing yet. Maybe I'll put one in the boat just to see what people. Yeah, because you're like electrofishing, and you're like, why are there's no fish coming up? There's a banana on the deck.
All right. Well, Jeremy, congrats on your next chapter.
Thanks. Appreciate it. I will definitely miss it here.
Cory, we're excited for you to take on this new role.
Thank you.
And Ryan, thank you for giving us the boots on the ground perspective and just this real insight into all things bugs that I didn't know I wanted to know.
Yeah, no worries. Anytime.
If you're out and about and you see a BRA truck pulled over near a bridge or a stream bed, give them a wave. They're out there doing the heavy lifting so the basin stays healthy. As always, thanks for joining us on Unpacking the Brazos River, and we'll see you next time.